All right, thanks so much. Welcome everybody. My name is Borshal, and I'm here to talk about building modern applications on Azure. How many of you have used Azure? Oh wow, so good. So then specifically what it means for DevOps. So this is a little bit about me. I'm a program manager on the Azure Compute team, and I'm responsible for our open source development and DevOps stories for our containerized and microservices platforms, meaning Azure Container Service, Service Fabric. I also responsible for the container integration with Azure Service Fabric, as well as working on a new service which is not being disclosed. I'm really passionate about distributed systems and microservices. So 2 years ago, I got into that space, really diving deep into containers and microservices. And as you can see, I'm coming from an enterprise SharePoint background, so I've been all the way to journey. So if you think about the session, it's a pretty broad topic. And I thought what I'm going to do is I'm going to talk briefly about why is this like modern cloud thing important, why are we seeing that at Microsoft, and why a lot of customers are asking for it. So I'm going to talk about that. Then I'm going to talk about the benefits of those modern applications. And when I talk about modern applications, you can think about modern applications / microservices. I'll also touch on the downsides because that's really important from a DevOps perspective, what you need to keep in mind. Then I'm going to talk specifically about what does this new flow mean for the DevOps flow, like the modern applications. Then I'll do a demo, and most of you are familiar with Azure, so I'll probably touch on Azure as an open platform because by now you probably know that we support Linux as well, and not just Windows, and we support pretty much all the languages that are out there and frameworks. So I'll briefly touch on that, and then if time permits, I'm going to show you a demo of how to work with Chef on Azure. Does that sound good? All right. So modern cloud applications, what's happening? What we've seen over the last like 2-3 years is that a quote from Satya, I think, describes it very well. He basically said every business will be a software business. And we've seen that especially with our traditional enterprise customers, because companies who haven't been traditionally software companies are getting into that space. One very popular example is car manufacturers. So if you think about Mercedes, BMW, like Lexus, all the big ones, they used to compare their products based on gas mileage, horsepower, and so on and so forth. But now the connected car notion becomes more and more important, right? So if you look at the new advertising of those cars, it's like, hey, it has Apple Play, it has like Google Play, it knows that there's another Mercedes ahead of me, right? So all those companies are moving more towards a modern cloud architecture, and all those systems are basically connected through the cloud. What that also means is they cannot rely on long release cycles anymore, right? So the way they've built software in the past, like big monolith and ship it like every 2 or 3 years, doesn't work anymore. Because customers expect constant innovation, constant updates. So that's what's really driving that, and we've been seeing a lot of customers doing that. So they want to do this, fast way to differentiate from competition. Again, car manufacturers is a really good example for that. They want to be fast to market. We've been talking to a lot of customers, and really key is, hey, we have a new idea. We want to connect those cars. My car should know that there is an icy road ahead of it because the other car tells my car that there is an icy road ahead of it. So they really want to be fast to market, right? And they want to be able to respond to failure and downtimes very quickly. And that's really what's driving it. But now you're actually merging two worlds, right? You merge in the traditional enterprise world, which is very constrained, and you may all know how enterprise DevOps processes or release cycles work, with a very modern, new type of service delivery method. Okay? So this is why this whole topic becomes more and more popular, and it's gaining more and more traction. Out of curiosity, how many of you have heard about the term microservices? There you go. So how many of you have implemented microservices? Okay. So just by the number of hands, it basically shows that like it's gaining a lot of traction. So what are the benefits of a modern cloud application? Why is everybody talking about it? So I already mentioned it enables continuous innovation through independent deployment, and that's really the key, right? Because if you're thinking about an application in a traditional sense, it's not just one component, right? An application is multiple components. But the problem with updating individual components who are responsible for certain functionality becomes really hard if you have that big monolith block, right? So if you go to this more modern architecture, you're enabled to basically update those components independently. The other important aspect is, if you think about traditional applications, they were all typically built on one technology stack, right? So you were building it on .NET, you were building it on Java, right? But the whole language or tools and framework landscape has evolved. There are tools that are really better for certain jobs than others. If you build those services independently, you can use different technology stacks, which is great, right? So if you think about, you have data storage needs for NoSQL, right? So you can use a NoSQL store with, like, let's say, a Node.js frontend, while you can use C# or Java for another application. The other advantage is, by breaking it down, those services can be built by smaller teams. That also means that you don't need to have those wise people in the enterprise that have all the wisdom because they've been working on a product for 10 years. And those are the only ones who really understand the 3 million lines of code, right? Because you're breaking it down into smaller pieces. The other important aspect, especially for the cloud, is by breaking down those services into smaller units, you have improved scale in your resource utilization. Because if you think about, you ship one application as one block, right? So what's happening typically is you take a copy of it and you scale it out, you put it on another node, and so on and so forth. By breaking it up, you can actually accommodate certain services that need a higher load than others. So for example, your front end receives a lot of requests. You can scale out the front end independently from your business logic. Because those services are actually independently coupled, it provides a fault isolation. So if something in your application or your service leaks or has a problem or crashes, it doesn't take down the entire application. And the other benefit is no downtime upgrades. So typically what's happening there is that you deploy a new version into production while the old version is still there, so without a downtime. So those are really the benefits of the modern cloud applications and why everybody thinks it's great. So if you think about monolith and microservice, how many of you have heard about the term monolith? Right. So there's nothing wrong with it, right? It's absolutely valid. And actually, you should always start out with building a monolith, right? Because that's what you're used to. And as long as that whole thing is manageable and you can publish it, it's perfectly fine. What's happening, what we recommend people to do is, we actually start breaking it up or refactoring it based on certain requirements. So let's say on the left-hand side you have 3 features, right? And feature A and feature B is basically pretty stable. You don't plan to develop it further, but feature 3 updates all the time. You probably want to think about decoupling it so that you have a different release cycle for that particular feature, for that service. Also, another reason for decoupling it is you have different scale requirements, right? So feature A may have a different scale requirement than feature B. So that gives you also more advantage in the cloud because you can actually utilize the resources better and you pay for those resources. Third one is different technologies, and the last one is really size. If that thing really grows big. We've been to customers, I personally have been to customers, they have like 3 million lines of code in their application, right? And even though the application is architected in a very SOA-based way, it actually takes a long time to ship that application because you have all those components that integrate, and now you have to do integration testing and so on and so forth. And it took them actually 3 months to get a new release out, and it was way too long. So from a microservices perspective, if you break it up, you don't necessarily have that notion of an application in the sense of the monolith anymore, right? Your application is just like a loose wrapper. That's why you have the dotted line. While all your features are independent, or all your services are independent, they can even have independent state stores, right? So every service is basically built around a business scenario, has a certain functionality, and it's self-sustained. That means that service can live in total isolation. And those things just communicate with each other through well-known APIs and ports. So how many of you are developers? Right, a bunch of folks in the room. So now you may have the question, wait a minute, that doesn't sound too good, right? Because there's a downside to it. There's a huge hype around it, microservices and the architecture right now, but there are things from a developer perspective that you really need to consider. Because now, think about you have an application with like 200 services, right, which is not very uncommon. You have a lot of network communication going on, so you have a very chatty application. Also, the data exchange, you need to serialize and deserialize data there. So that's something you need to think about, right? Then if you have all those independent services, they're really hard to test in isolation. So your developer, right, they need to have somehow a way to test like dependent services and so on and so forth. The other one is how to debug or monitor across the services. Because especially if they're built by different teams, right? So you need to agree on a certain logging structure, logging semantics, logging infrastructure, and so on and so forth. Then also, if because your user request actually spans multiple services now, you need to think about having things like correlation IDs or activity IDs that you can actually trace the request from when it hits the load balancer all the way when it returns to the user, right? Those are things you need to keep in mind. And new service versions must support old and new API contracts, because if you're especially in this very dynamic world of CI and CD, you need to make sure that when you roll out a new version of your service, because you roll it out completely independently from others, right, that you don't break the services that are out there. And what it basically comes down to is DevOps persona trade short-term pain for long-term gain. So there's a lot of work to do in this modern cloud applications. I think that's what that slide should say. Don't think about, hey, it sounds all great, it's super easy, right? There's a lot of work you need to do, especially from an automation perspective, from a monitoring perspective, and so on and so forth. Good thing is, there are tons of open source tools out there, and I'll talk about them that are supported on Azure. Does it make sense so far? Yeah. All right. So, word on containers. I added a slide. I was debating whether I should add it or not. How many of you are familiar with containers? Okay. So, you played with containers? Okay. There is this statement. Every once in a while, you see like a statement: microservices versus containers, microservices and containers, right? So that's not really accurate, because microservices is an architectural pattern. You can't build microservices completely without containers, right? Containers are a tool that often help with implementing microservice-based applications. From a DevOps perspective, I mean, most of you are familiar with that. It's really great because it encapsulates the application environment. So you have everything inside your container image, right? All the dependencies, you don't need to install it on the host. So every dependency for your application actually travels with the container. And by that, you have that immutable environment, which is consistent through all the underlying environments. So it comes down to you manage an application instead of environment. You can use generic APIs. And what's really cool about containers from a DevOps perspective is you actually control the usage and the telemetry through the container, because typically you have one service per container. Right? So I don't want to get into the containers too deep, but there's quite some advantages in a DevOps perspective why you want to use containers. All right, so the overall DevOps considerations, what we've noticed is, like, it's not rocket science, right? You can automate everything, right? But what we've seen with a lot of enterprise customers is really, if you want to embrace this modern microservices / modern cloud flow, it starts with organizational challenges. Okay? Because many of enterprise organizations are not built in that way. Like born in the cloud customers like Amazon, Google, Twitter, they're all built differently. If you look at their DevOps or how they roll out code, it's very different than a typical enterprise. Right? So if you want to embrace that, you need to have a rethinking there. Because the notion is, you build it, you run it. Okay? So the teams that are building those services, they deploy those services, and they're responsible for those services. This is, in my experience, is taking it a little too far for many enterprise customers, because all the red flags go up and the IT department say, no, I'm not going to let my developer deploy right into production, right? It's way too dangerous. But this is basically what it comes down to. Testing. Testing services in isolation do not do not offer much value. As mentioned, if you have one service, you can test that service, yes, but you need to test the service with interaction, so you need to think about what you're going to do there. Unit testing in that sense only provides limited help. So in the end, from a testing perspective, a guy from Twitter said it very well. You need to decide between safe and fast. Right? So if you want to deploy really fast, you're probably lacking a little bit of the testing part, and you need to trust it that if you deploy it into production, that you either have systems in place that if your upgrade breaks, that it rolls back while your old version is still available, or you say, no, I want to play it safe, and then you go through like thorough testing, staged environments, and so on and so forth, but that comes at the cost of agility, right? So this is the trade-off you need to do. The other part is really from a DevOps perspective. If you think about all those independent services, because typically what's happening is you deploy those services into clusters, right? So you're talking about distributed systems here. That means you don't marry a service to a node anymore, because if that node goes down, the service just gets spun up on another node, right? That's just what's happening. So now, your node name or your node IP has changed, and so has the endpoint of the service, right? You need to think about systems like service registry and discovery, where when those services come up, they say, hey, my name is front-end service, right? And I can be found here. And then you need to have a key value store that actually keeps that information so that other services can actually resolve the endpoint, no matter where this service ends up in a cluster. So those are things you need to think about. And from a DevOps perspective, there are different ways of service registry and discovery. So you need to think about whether you want to make your service known to the system or your system detect the service and so on and so forth. So there are a bunch of things. Service communication. So if you have all those services talk to each other, what kind of communication mechanism, what kind of protocol are you using, what's your security requirements, right? So those are things you need to consider. And then to the end, monitoring, and I mentioned that before. So this is a slide, and that's by no means meant to be like guidance, but this is what we've seen with traditional enterprises versus modern DevOps flow. So traditional ones, quality of code check-ins, I mean, unknown is a little bit over the top, but there's some measurements and things like that. The environment creation was typically manual, right? So you went down to the IT department and said, hey, spin up a bunch of servers for me. The deployment frequency was max 1 to 2 times a month, or even less frequent. We had a lot of enterprise customers who deploy like 3 months, 6 months. And some of those things are not because they don't want to ship sooner. It's really coming down to all the testing stuff that I mentioned before. App deployment process requires meetings and plannings like, okay, what's the new feature set? Are we breaking someone else? And so on and so forth. Deployment validation was typically manual. Monitoring of the system was minimal to none, and what that means is there was no telemetry at all, right? In most of those systems, there was monitoring or logging, so errors were thrown, were collected. But there was no telemetry, or there's not typically a lot of use of telemetry where you know how your app's behaving and things like that. And DevOps and relationship, it was almost like a blame culture. Oh, and we had that in Microsoft, to be honest. I mean, I'm part of the engineering team. We rolled out things and like the dev checked it in, right? And we broke it, and the release manager didn't catch it, and the test manager didn't catch it. Right? So if you look at the new ones, and this is actually the modern DevOps flow, and we do that to a certain degree for our own Azure services as well. We validate the code check-in through unit tests and other tests there. Environment creation obviously is automated. So it follows like the infrastructure as code approach. We automate the environment creation, we roll out the new clusters and so on and so forth. We deploy whenever needed, including several times a day. And that's, especially if you run services, that's what we do quite frequently, even in Azure, that we roll out new versions. You don't even notice it, okay? So it's, the deployment itself is a push button deployment. There is not much synchronization going on. It's really like a bunch of checks, and when everything shows healthy, it goes out, and then we have some sort of stage deployment into our data centers, but it basically comes down to, okay, every system shows green, we just deploy it out there. There is no manual interaction. Deployment validation is also automated. Everything is very well monitored and telemetry driven. So we also know those services, for example, if they have have some impact on performance and so on and so forth. So we try to monitor those services and get telemetry to tell us even that something's wrong before it breaks. Right? So because sometimes you have some indications, hey, that service is slowing down, right, for some reasons, and there might be a problem with the network. So we have extensive monitoring and networking, and that's what a lot of those cloud applications have. And Dev and Ops relationship is really a culture of trust here. So it's no blame culture. It's like, okay, I need to trust my developers to ship a new version. So that's the major differences here. Here's a sample microservices application DevOps flow using containers. And if we look at the slide, we actually have 3 services here, service 1, service 2, and service 3, right? It's using a staged environment, but key here is that, especially if you work with containers, you're not just building your code. At some point, you need to build your container image, which is your immutable environment. And what's happening here is you basically check in, or a developer checks in the code into a repository. The repository actually says, hey, I have new code available, I need to do a build. What it does actually is a build, and it also builds a container image. And then it puts that container image in some sort of registry. It could be public Docker hub, it could be a private registry within your cluster, or your private registry within your data center. So from that point on, you actually have the immutable environment. That's now an image of your service, or your service packaged into an image with all the dependencies required, right? And then that does a deployment into dev cluster, QA cluster, or pro cluster. So there's still a valid use of stage deployments there. We've seen that quite frequently. The key takeaway of the slide is each service has its own repo. Each service has its own CI/CD pipeline. I think that's the thing that's very different to many of those old traditional applications. And staged environments can be used, but don't have to. I mean, we have enterprise customers as well as startup customers. A lot of startup customers, there's a cost thing, but there's also like a different, because they just start out with an application and they do testing in production. If you do testing in production, feature flags and things like that, that also adds to your automation work you need to do up front. All right, so that was a lot of talk, huh? Did that make sense at all? You want to see a flow like that? Okay, let's do this. The first thing I'm going to do here is I'm going to SSH into a DCOS cluster. DCOS is Data Center Operating System, which is basically a bundled version of Mesos with Marathon. How many of you have heard of Mesos Marathon? Okay. Think about it, it's like a cluster management system. It basically controls your machines. It knows the state of your machines, if the machines are healthy, and then it has a schedule on top of it, which is Marathon, that actually takes the services or containers and deploys them into the cluster, and then it also knows, hey, that service is down or that container is down, trying to restart it, and so on and so forth. So I SSH'd into this one, and that's actually big news. See that? No? Okay. So I set up a tunnel to a local host when I SSH'd in, and this is the UI. But what I really want to show you here is, if I go into Marathon, it's a service, I see a bunch of applications running in here, right? And this could be my microservices, right? So think about all the entries you see here, except the Jenkins one, being like microservices, okay? So those microservices are running, they're all healthy, they're deployed, right? So now what I want to do is, I want to deploy a new version. Let me show you, for doing that, let me show you the old version first. That doesn't work. So this is the old version. It's a very nice website, as you can tell. I'm a gifted web designer. And in here, if I click demo, I deploy one microservice application. Okay? So now what I'm doing is, think about it. I have the source code here, and I'm not just a gifted web designer, I'm also really good at HTML, as you can tell. So I'm going to update this one, right, and say v2 test. And what's happening now is I'm going to save that code. I'm going to do a git commit. It goes into my GitHub repo. What's then happening is it actually triggers a build. It's actually a Jenkins build, because Jenkins gets a notification from GitHub and says, hey, I have a new version. And then Jenkins builds this new container image, uploads that container image to the registry, and deploys it into my application. Make sense? All right, let's try that. All right, so let's save this one, go to my command line here, and what I'm going to do is a git add, and then I'm going to do a git commit demo. And then I'm going to do a git, what do I want to do? Git push origin master. Alright, so now it's pushing it up there. Hopefully, yes. So if I go into my Jenkins console, this is actually my Jenkins project, you can see that it starts queuing a build, right? So by the time I checked in the code, into the source repository, it gets the notification, down to Jenkins, and Jenkins says, hey, you know what? I have new code, I need to build that image. So what's happening now is, it starts to build, and if I go to hub.docker.com, this is my container registry, think about that, what I've shown you, and I go to this front-end one, and I see my different versions. In a few seconds, I should actually see a version 5 popping up. So that's my new image with my new source code, everything baked in, right? Once that image is in my Docker hub, and again, it could be a private registry, I can just grab it, or Jenkins grabs it. It does a continuous deployment as well, and pushes it into the cluster. And there is no interaction whatsoever. It's a fully automated flow, right? I understand this is like, for many enterprise customers, it's like, ooh, that's scary. But you can think about that flow also using that type of flow in a test cluster, right? There is nothing against test cluster. It gives you a lot more agility here. So if I go in here, you can see image 5 is here with the tag. Let's see, the build is through. And then if I'm going to go in here, that's not good. I have v2 tests, so it was a load balancing problem. But that was basically an end-to-end CI/CD flow of a very modern app. Did that make sense, guys? All right. So now that we talked about modern applications, what you need to run those modern applications is a great platform. And this is Azure. So Azure is really, think about Azure as a super open platform. So the example or the services, principles, or the patterns I talked about can have many underlying systems, right? You can run this on, so for example, Service Fabric, which is an Azure service. You can run this on Mesos with Marathon or Azure Container Service. And you can also run things like that on Cloud Foundry or Red Hat OpenShift or Kubernetes, right? Key is that from an Azure Compute Platform overview, we think about it as a very open platform. So we support anything that's out there. And if you guys have certain requirements, talk to us and we enable it. Because we do understand that you made significant investments into technologies, you build your skills around it and so on and so forth. And what we really want to do with Azure is we want you to keep your skills. That's why we open it up, and I'll talk a little bit later about that. But from an Azure platform perspective, the way you can think about it is, of course we have Azure, and then we have Azure Stack, which is our on-prem equivalent. But everything is based on virtual machines and virtual machine scale sets. So virtual machine scale sets is worth noting because if you think about scaling out traditional virtual machines, There's some problems with that, right? So it works, but setting up a new instance of a virtual machine takes a while to boot it up, right? Then also if you run applications on top of it, you need to make that virtual machine known to the load balancer, you need to open up endpoints and so on and so forth. So what we had to do, or what we've done in Azure, is we built a thing, it's called VM scale sets. And a scale set you can think about as a multiple copies of an identical VM. So what we do is you start out and say, hey, I want to have 2 instances of that virtual machine, right? And if certain thresholds are reached, scale out to like 10. And the scale out is typically really fast because when we initiate a scale set, we over provision. So it goes really fast. But the other advantage is it's automatically hooked up to the load balancer. So if you have an application running on or listening on port 80, that VM will also have port 80 open to the load balancer, and the load balancer can start directing traffic there, right? Think about this. I already talked about, no I haven't. So in order to get software on there, like for example, Chef, right, is a very good one. We have a very good extension there. You use what we call extensions. So think about, you provision a virtual machine and you say, this is the machine I want, and then for example, I want to have Chef take control over it, apply compliance and so on and so forth. To get those components on the virtual machines, we're using extensions. And there's Chef extensions, we have security extensions, we have debugging extensions, we have runtime extensions, right? So, and then with the VM scale sets, that's really our, what we call scalable platform as a service layer. Because now we have the dynamic scale capability, so we can put all the PaaS layers on top of it. We have Azure Service Fabric is one, Azure Container Service, Azure Batch, and then all the other ones we support and have partnerships with. Then there is this, I drew this red line because we also have a bunch of what's almost like, we call it vertical PaaS. So it's, if you just want to quickly spin up a scalable website and things like that, you can use our top level services. The key takeaway from that slide is it's actually almost like Lego blocks, right? The way Azure Platform is structured. And the lower you are in the stack, the more control you have of the infrastructure. The higher you go in the stack, the less control you have, but you gain more productivity, right? So you don't need to worry about anything infrastructure related. So Azure is an open cloud, I mentioned it before, and that slide, I did quite a bunch of talks in Silicon Valley over the last 3 months, and that slide blows away a lot of people. Not just because of the black background, and you cannot see everything, but you get the idea, right? So Azure is really an open cloud, and as I mentioned before, it's not just a passphrase and we say, hey, you know what, open source, we're in, right? No, it's truly a fundamental principle of how we design and build Azure. It's really a lot about the community, because we want to enable the community on Azure. We want the community to use all the tools and frameworks they're used to use. We want to keep people, or that people can keep their investments into their knowledge, into their tools, into their chains, right? So, and if you look at the entire stack, we have a lot of, pretty much for each area, we have a lot of partnerships here. We have very strong partnerships, like with Chef, for example, or Red Hat OpenShift, that is very deep partnerships. But then another example of a partnership is, for example, with Kubernetes, right? Kubernetes is a cluster management orchestration solution from Google. You may think, oh, Microsoft and Google, that doesn't work well together. No, it's actually not true. We actually have developers working on the Kubernetes code base, right? So to make it really easy to spin up Kubernetes on Azure. So think about that slide as, okay, Azure is really open. We have certain forms of partnership, which range from, hey, we just contribute OSS to the community in terms of Kubernetes, for example, all the way to, we have full-blown support partnerships. So for example, if you run OpenShift on Azure and you have a problem, you just call Microsoft, right? And we take care of the Red Hat problem for you. So this is really the key here on that slide. Any questions on this slide? Nope? All right. So demo Azure and Chef. Oh, I'm going to land exactly at 35 minutes. All right. How many of you have used Chef on Azure? There's so many people, I don't even need to show it. All right, so let's start with Azure. You all know, because you all raised your hand, about our new beautiful portal. How many of you like the portal? Have you said? Oh, very good. All right. So if you're in the Azure portal, we actually have, this is my history, we have Chef Server and different variations of Chef Server. You can just go in there and easily provision a Chef Server. It's using Azure Resource Manager, so you can enter all the information about VM size and so on and so forth, right? So that gives you the Chef Server, and I already done that, of course. And this is what you get. It's basically Chef management console. It's very easy to set up in Azure, and you can fully automate that, right? So now you have your Chef Server. If you want to add Chef or the Chef client to any of our virtual machines, this is where the extensions come in. If you go back here and I say I want to create a new virtual machine, typically create a virtual machine, entering my name, and then, just for the record, let's use this key here. So entering my SSH key, and then I create a resource group. Okay. Hit OK. So I'm choosing the size. I just picked the default one right now. But key here is what I really want to show you guys is then I go to extension, and again everything is can be automated through Azure Resource Manager. So it doesn't have an extension, but what I'm going to do here is I have this extension gallery, and in the extension gallery I have a Linux Chef extension. I have the same for Windows if I have Windows machines. I just hit it, say create, and in here I just enter my Chef server URL, Chef node name, my run list, client validation name, and so on and so forth. Then you kick off the provisioning of the virtual machine, and then it basically turns into a Chef node. Very, very easy, very straightforward. You can either use our CLI, our beautiful portal, or Azure Resource Manager with the CLI. And with that, I'm done. Any questions, guys? Yes?
Can I see your Jenkins job build section?
Yes. Question was, can you see the Jenkins job? I'm more than happy to show this. So this is...
I've seen a Jenkins job run before. So I'd like to see how you got
fair enough.
ran.
Yes, let me go here. That's what you want to see, right? So in here, source code management, I basically point to my GitHub repository. So far, so good. Then I'm using build when a change is pushed to GitHub. Here I'm building the image. And I'm using Jenkins environment variables for my Docker account hub and so on and so forth. So the way I build my image here is, as you can see, I use the build number as my tag. Because there is, if you guys are familiar with Docker, there's some I wouldn't call it dangerous, but Docker has this notion of the latest tag, which is not necessarily the best thing to use, because latest tag on a Docker image doesn't mean it's the latest image that was built. It actually means that's the latest image that wasn't tagged. It's in the global settings under environment variables. So you go to Jenkins global settings and then add environment variables. So this is what it does here, right? And then I have a post-deployment step. Oh, I should probably mention, as you can see here, I'm doing the Docker push. I'm using the Docker command line. To do the Docker push, it pushes it up to Docker Hub.
Is there anything wrong with using PowerShell?
No. Well, I mean, no.
Shell is just, actually, no, that's
I mean, yeah, that's Linux. The reason why I said no is if you use Windows containers, you can use PowerShell. And then what I'm doing here is I have a Marathon deployment plugin, and we have a bunch of deployment plugins. This one is written by Mesosphere, and what that does is I just pointed to the leader Mesos Marathon. What I should mention here though is my cluster. The way I set up my cluster is I have special agents or agent nodes just for the build. So they are not on my application. So it's basically I'm doing the build within the cluster, and that's why I can just point it to the leader here, and then it just pushes out a new application. It's using Marathon REST codes under the cover.
Or is
So-
that a separate agreement?
The question was if I can say anything about the server licensing for Chef Server on Azure. The answer is unfortunately no. I'm like, I really don't. You probably want to talk to some people from Chef, or we have also Microsoft people from, I think, our field department. They should be able to help you there. So the question was around like our monitoring story on Azure for containers and things like that. So we have a very basic functionality out of the box. It's called Linux Azure Diagnostics. We have the same equivalent on Windows. It's called Windows Azure Diagnostics. But that doesn't get you very far. It's basically a very, almost like a dumb agent that just collects the logs, transfers the logs into storage account, or you can transfer them in an ad cluster. So what's shaping up now, I would recommend, is you use like Datadog or some of those, or New Relic. Those solutions are really good because they're like, they basically span the entire spectrum. They're really good. From Microsoft itself, I think we have, it's called Operation Management Suite now. It's basically, they all follow the same principle with containers. They have a monitoring container that you deploy into your nodes, right? And then it reads out the data out of the C groups. It needs elevated privileges and things like that. But if you use one of those like end-to-end monitoring solutions, that's probably the right way to go, because from an Azure perspective, we're really unopinionated there. All right, so the question was, you can create images, container images of Ubuntu without licensing implications. How does that work for Windows containers? So Windows containers are currently in TP5, Windows Server 2016 TP5. What you need to do is you need to sideload the base images onto the machine, and there is in Azure, there is already a virtual machine that says Windows Server 2016 with containers that has those base images loaded into the private repo on the machine, and then you can put on top of it, and those things you can put into Docker Hub. But you cannot distribute the base images currently. Does that make sense? Yes. So I think, and that may change in TB5, right? But I think that's a very solid model, and we can follow up on that. But the current thing is, you couldn't take the base image of a Windows Server container based on Windows Server Core or Windows Server Nano and take that base image with any additional layer on top of it and put it somewhere and say, hey, I distribute just the Windows base image. But as soon as you put a layer, meaning like do a customization on top of it, it's fine. You can put it into Docker Hub. Great, and thank you for coming. Hope it was useful. And I'm going to be around.